Hello everyone, my name is Eric. I currently work as an electrical instrumentation and controls engineer based in Chicago, and I also have a bachelor's in electrical engineering. So today's topic we'll be doing is circuits, and we'll be solving circuits utilizing nodal analysis based on what the question is asking. And so I'll have a couple problems we're going to go throughout the video, and we're going to try to solve them together. So let's get started. So for nodal analysis, what we're trying to identify is the voltage going at a node. So in this case, we have a circuit, and in this case, we're trying to solve for Vx. So for these kinds of problems, we have a way of figuring that out, and that's by utilizing a method called nodal analysis. And so what we would do is identifying where the node is and what we're solving for and what's surrounding it. So we see we have a Vx value here. On this side, we have 100 volts going through a 20 ohm resistor, goes through Vx. And then we have on this side a 5 voltage source going through a 30 ohm resistor. And then over here, we also have a 10 ohm resistor as well. So we've identified all of the aspects for this circuit. So let's try to solve it together. So what we do is, in this case, is when we're trying to find the voltage going through it, my recommendation is having arrows pointing out this way. And the reason why I like having to do this is because then we can kind of organize our thoughts and the way we would format this problem. So in this case, what essentially these arrows are saying is that I'm going to take this voltage subtracted by this voltage and divided by this resistor, which will give us a current, right? So if we go along and try to solve it, so for this side, what we do is we do Vx minus 100 volts divided by 20 ohms. So that's the first part over here. Next thing we're going to go through is this 10 ohm resistor. Now what's different about this is that there's no voltage source, right? So we're just going through the 10 ohm resistor straight to ground. So all we do is plus Vx over 10 ohms. And the last one we see is Vx minus 5 volts over 30 ohms. Awesome. And so the only thing left to do is just solve for Vx, and we have a bunch of variables, right? Or in this case, we have a wide range of different denominators. So we have 20 ohms, 10 ohms, 30 ohms. So to make our lives easier, we're going to go ahead and make it 60 ohms. So if we're going to make the denominator 60 ohms here, so essentially I'm doing is multiplying this by 3, which means I have to also multiply the numerator by 3. So in this case, we put a 3 here. We have 3Vx minus 300 volts, and this will be 60 ohms in the denominator. The next one is we're going to multiply this by 6, so we get 60 ohms in the denominator, 6Vx in the numerator. And the last one, we're going to multiply this by 2, so we get 60 ohms in the denominator again. And then here, we're going to multiply this by 2, so it gives us 2Vx minus 10 volts. Awesome. So obviously we have all our denominators, it's set, it's all equal, so we can just ignore the denominators and just solve for what we have in the numerator, right? So we have 3Vx minus 300 volts plus 6Vx plus 2Vx minus 10 volts equals 0. And now we're almost there. All we have to do is add the ones without the variables with this. So in this case, we have 3 minus 300 minus 10. So what we're going to do is we're going to put those negative values on the other side. So minus 300, minus 10, minus 310 on the other side, which gives us positive 310 volts on the other side. And then here we have 3Vx, 9Vx plus 6, so 9Vx, 10, 11Vx, so 11Vx over here, right? 6, 7, 8, 9, 10, 11, yeah. And then if you have a calculator, all you do is 3 is 10 divided by 11, and we get the voltage going through that node exactly is 28.18 volts. And so the last thing I recommend for people to do is that once you have the value of Vx, try to determine if that makes sense, right? Because if, for example, I got, let's say, 280 volts, that doesn't sound right, right? Because I have 100 volts here, I have 5 volts here, so it can't be 280 volts there. It doesn't make sense. So 28 volts being there makes sense because we have 100, it goes through a bunch of resistors, we have 5 volts over here. So realistically, that does make sense. Okay, I'm going to erase the board and we're going to get through another problem. And we're going to make it a little bit more difficult as well. Okay, so I've set up the next problem, and essentially it's going to be a little bit more difficult from the previous one. But we'll still be able to break it down into smaller pieces and then eventually get to a solution. So looking at the question, what's different about this one is that now it's asking what is the voltage at V1 and V2. So now we have two nodes that we're going to have to solve for and figure out what their voltages are. So that's the first big thing. The second thing is looking at the components of this circuit, we see that the left hand side, it's similar to what we saw from the last problem. We have resistors, we have a 10 voltage source. But then when we get to this part, we see that the V1 and V2 are across this, are right across from this 2 ohm resistor. So that's the first difference from the last problem. And then the other thing is that instead of having a voltage source on the other side, we now have a current source. But besides that, I don't think there's anything here that really makes this problem too difficult. I think it's perfectly something that it's right up in our alley. It's definitely something we can solve. So let's get straight into it. So what I recommend us doing is with all the voltages, giving it all the nodes directions with arrows of how we're going to go about it. So then we can visually see what's going on, right? And so let's start with the left-hand side first. So in this case, we're going to go with what we did last time, if you remember. So we're going to do V1 minus 10 volts here, divided by 1 ohm. And then over here, we have plus V1 over 5, and then plus V1 minus V2 over 2. So that's how we would do it in this case, right? We're just going to imagine V2 has a value already, but in this case, we don't know what that value is. So we're just going to have to leave it as V2, and then we're going to make this equal to 0. Okay? Now we're going to solve for V2, let's try to solve it as well. So in this case, we're going to do V2 minus V1 in this case, because it's going right across the 2 ohm resistor right here. Then we're going to do V2 plus V2 over 10 ohms plus, in this case, we notice that our arrow is pointing in this direction, right? But the current source is going the opposite. So actually what we're going to do is, in this case, we're going to put minus 3. And then we're going to make it equal to 0. Okay? And then my recommendation is essentially giving it all these functions a common denominator. So for the first one, I'm going to put it over here now. We're going to make the common denominator 10. So if I do times 10 here, we're going to make this 10. To make this 10, we're going to multiply this by 2. And then to make this 10, we're going to multiply this by 5. Okay? Good so far? So we're going to go from the left. We're going to go 10 V1 minus 100 volts. But we're just going to keep it at 100 plus 2V1 plus 5V1 minus 5V2. Okay, good. This 2 is pretty sloppy. Let me fix that. And then for the second one, our common denominator should probably be 10. So this one's not going to change. But what we also have to consider is that when we multiply everything by 10, or have a common denominator by 10, we should also have this multiplied by 10, right? So if we multiply all this by 10, or make this at least the common denominator 10, right? So this should be times 5. So this should still be 5. So keep that. And then this we still have to do times 10 for. So then it fits for the situation we have, right? So we have 5V2 minus 5V1 over 10, right? Plus V2 here stays the same, minus 30. So actually we can move the 30 on the other side, but before that, let's just see if this is right. Yes, okay, good. So now we should have these set to 0 or whatever we think is best fit for this. So if we look at, so this is number 1, this is number 2. So in this case, for number 1, we can have the 100 to go. Well, these are also, by the way, equal to 0. So in this case, for the first one, we can make it move the 100 to the other side. So we can make it 100 is equal to 10v1 plus 2v2, 2v1 plus 5v1 minus 5v2. And then for the second one, we can move the 30 on the other side. So we have 30 equals to 5 plus 1. So it makes this 6v2 minus 5v1. Okay? And then, oh yeah, we can also combine these. So it would be 100 equals 10, 11, 12, 17, 17 v1 minus 5 v2. Okay, nice. And then all we have to do here is essentially kind of have like a systems of equations kind of going on, right? And so I think the best thing we should do here is actually do 100 equals 17 v1 minus 5 v2. And then over here we can do 30 equals minus 5v1, we set it up the same way here, plus 6v2. And so because we have system equations, we can solve for one of the variables. So in this case, I think v2 would be easier to take out. And so we're going to multiply this by 6 and multiply this by 5, this whole thing. And this is going to all be multiplied by 6. So we're going to do 600, which is equal to 17 times 6, which gives us 102, minus 30 v2. Wait, what? 17 times 102, oh, v1, that's what we're missing. And then over here, we're going to multiply this by 5. So 5 times 30 is 150, which is equal to negative 25 v1 plus 30 v2. So it's nice as we have a negative 30, positive 30, that can cancel out. We can solve for v1. So add these, so we have 750, which is equal to 102 minus 25, which gives us 77 v1. And then over here, 750 divided by 77, which gives v1 to be 750 divided by... Sorry about that. My phone died. So we left off with solving for v1, which was 750 divided by 77. We get 9.74 for v1. So v1 voltage for v1 at the node is 9.74. And then all we can do is, there's two system equations we could have used. I just grabbed the first one, and we could just plug in 9.74 to v1. So we get 102 times 9.74 for that, equal to 600 minus 30 v2. So for this part, we can do 102 times 9.74, which gives us 993.48 equal to 600, and then minus 30 v2. And so we can do 600, move this to the other side, which is minus 993.48 equals minus 30 v2. So then we do 600 minus 993.48, which gives us 393.48, which is equal to negative 30 v2. So v2 ends up becoming negative 30. You divide negative 30 on both sides here. So v2 becomes negative 393.48 divided by negative 30, which gives us v2, so the voltage at node 2 is 13.116. Awesome. So if you guys have any questions, you're more than happy to leave any comments. Make sure you like the video if you guys like this. And yeah, hope you guys enjoyed.